Welcome to HP Tuner's GM Gen 4 Training Part 45. This training module, we're going to take a look at how we can dial in both the mass airflow and the speed density operation at the exact same time. So we're going to be looking at the simultaneous calibration method that's going to be relying heavily on math channels in our VCM scanner. We're going to go over the basics and how everything works in this tutorial. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our simultaneous calibration option for both the mass airflow and speed density for our Gen 4 vehicles. What this is going to allow us to do is dial in both the mass airflow and speed density at the same time, so no longer do we have to put the engine control module into a math-only mode or speed density-only mode, as I showed previous in our training course. So over the last year, I've been working with this hybrid type of simultaneous calibration method, and it's worked out really well on Gen 5 vehicles, and I found that it actually works on Gen 4s as well. So I'm going to be sharing with you how this works and how you can apply it on your Gen 4 vehicle. Now, the older calibration methods of putting the engine control module into math mode or speed density still will work, but we can accomplish essentially the same outcome with half the work or half the time spent in doing the airflow modeling calibration process. So this is a superior way to go about things, and this is the way I've been working with doing any tuning on Gen 4, Gen 5 vehicles in the last year or so. I wanted to update the training course so you have the most relevant training material at the time that you're watching it, so we're going to be adding this in as an additional video in our training course library. Let's jump in here and talk about how the airflow model works just briefly here. We've covered this before, but I'm just going to do a recap here in the beginning of the tutorial. Then we'll jump into the VCM scanner and talk about some of the nuts and bolts of how this is working behind the scenes so we can just understand what's going on here and how and why we want to work with this simultaneous calibration option. So first things first here, I'm jumping into my 2012 Yukon Denali calibration file. Any Gen 4 calibration file will work to follow along for this training module. What I'm going to do is jump in here to the engine tab, and I'm going to go in here for my general into airflow. Now under airflow here, we have our mass airflow calibration curve. We also have our speed density VE coefficients. Now this would be relevant for virtual VE programming. If we have a 2-bar operating system, we could click this. We could convert it over so that it didn't have the virtual VE to worry about, which we've covered in the training courses previous to this. So we know that if we don't have our VE coefficients being present because the 2-bar patch was applied, then under general here, under the VE area, we would find that we would have a traditional VE style table or a volumetric efficiency table that we could dial in and tune. Now in either situation, whether we're dealing with virtual VE or we're dealing with the 2-bar operating system volumetric efficiency enhancement, we are able to dial both the mass airflow and the volumetric efficiency speed density in at the same time. And we can do this based on doing some quick math crunching, looking at closed loop fuel trims or looking at open loop conditions at a wideband input, and then running some math channels, and it'll start to figure out the differences or deviations between the mass airflow, what it's registering and reading, and then what the speed density is registering and reading in terms of the estimation of airflow. And then it's able to figure out a percentage of difference, telling us how much we need to adjust and update our mass airflow curve and our volumetric efficiency. So it's actually relatively straightforward, although it seems complicated, but we'll go through all the details in just 1 minute. But let's just focus right now on talking about how this airflow model actually works. So in our mass airflow calibration table here, we should understand what this table means, but let's just go over it real quick. This table is going to be based on a frequency input coming from our mass airflow sensor, and at a certain frequency, it's going to look up a certain airflow amount that it's going to be having as a basis. Now this is a raw, unfiltered mass airflow lookup, so it's a 1-to-1. There is some filtering that goes on in order to produce an actual mass airflow reading so the engine control module can use that in the fuel and spark timing calculations and going through and working with that. But what we will find, it is a pretty straightforward lookup here. So frequency output from the sensor as the airflow passes over it. It looks up in the table here at what that amount of airflow should be, and it uses that in the equation of fuel mass is equal to air mass divided by target air fuel. This is where our air mass comes from in that equation. Now, we're going to find we have this other option or other airflow method that's going on at the same time, and that's going to be our speed density operation. Now the mass airflow is measuring the amount of airflow coming into the engine while the speed density is estimating that amount of airflow. So when we have a virtual VE table here, for example, talking about virtual VE, we'll find that this table right here, this is based on estimating the amount of airflow coming into the engine rather than measuring it. We can't measure with a VE calculation like this, but we can estimate that airflow. It's our job to be able to calibrate the volumetric efficiency table so that we're estimating the airflow properly, and that at any given time, depending on how our airflow model is calling on either the measurement of airflow coming from the mass airflow or the estimation of airflow coming from the speed density, that they're going to be accurate. Because if they're not accurate, our fueling and spark timing calculations will be thrown off and our vehicle won't run properly. Now, as we're talking about this, real quick, I'm looking at something like our mass airflow table. When we are registering the amount of air mass under steady state conditions, the engine control module prefers the signal from the mass airflow sensor, meaning it's going to more heavily weigh on what's coming from the mass airflow table rather than weighing on looking at what the estimation of airflow is going to be from the speed density. Now there are hybrid. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.